Let's solve this question from scratch. A company has a standard sheet of 25 meters. Customer requires 5 meter pieces, called 100 pieces, 8 meter pieces, 80 pieces, 10 meter. So we can say that desired width. Customers desired meters. Customers want 5 meters. They want 80 meters and they want 10 meters. And the 5 meters, they require 5 meters is 100 pieces, 8 meters is 80 pieces, and 10 meters is 60 pieces. Good. We want to minimize wastage. Formulate L.p.p. Let's formulate our L.p.p problem. Good. Now, the standard sheet comes in 25 meters. The standard sheet comes in 25 meters. So let's see how best we can solve it. So we have 5 meters, we have 8 meters, then we have 10 meters, then we have wastage. So how best can we solve this one? The item is in 25, the size is 25. So can we cut 5 from 25? Yes, we can cut 5 from 25. How many times? We can cut 5 times from 25. That means that the 8 we won't get some, the 10 we won't get some. 5 times 5 is 25. There will be no wastage, 0 wastage. Okay, another thing we can do is we can cut 5 3 times, 8 0, then 10 1. So when we cut 5 3 times, it will be 15. We can cut 10 out of it, 15 and 10. That will give us 25. Wastage 0. Another thing we can cut 5 3 times, cut 8 1 time. That means we cannot cut 0 from 8. 5 3 times will be 15. 8 1 time will be 8. 8 plus 15, that will give us 23. Then our wastage will be 2. You've seen how we cut the patterns. Okay. Good. Let's see another method we have for cutting the patterns. We can cut 5 only 1. Then cut 8 twice. This will be 0. When we cut 8 2 times, it will be 16. Plus 5, we cut 1, it will be 5. 5 plus 16, that gives us 21. A wastage of 4. We can cut 5 1 time, 8 0, then cut 10 twice. When you cut 10 2 times, it will be 10, it will be 20, then it will be left with 5. Then we can cut 5 from it. So our wastage will be 0. We can cut 5 1 time, cut 8 1 time, cut 10 1 time. So this is 5 plus 8 plus 10. That will give us 23. Wastage will be 2. We can cut 8 3 times. Here will be 0, here will be 0. Our wastage will be 1. 8 times 3 is 24. So these are the patterns we can cut. You can arrange it however you want. Okay? Yes, with arrangement, you can do it whichever way you prefer. You can do the arrangement whichever way you prefer. Good. Hold on. Let me adjust the camera so that everything will be okay for you to clearly see. Now, since we want to minimize wastage, we use this as our objective function. This one will be x1, x2, x3, x4, x5, x6. and x7. Good. So we want to minimize wastage. So x1 is 0 x1. You can decide to write, I don't want to write it, 0 x2. x3 is 2, so 2 x3. x4 is 4 x4. x5 is 0, I don't want to write it. x6 is 2 x6. x7 is 1 x7. Like I told you, you can arrange it anyhow you want, depending on how you arrange your patterns. So my x3 can become somebody's x4. So somebody will get x3 as 4x3. It depends. But at the end of the day, we need to get these values. We need to get 2, 4, 2, 1, 0, 0, 0. So we need to get this. But the arrangement does not matter. The 2 can be here, the 4 can be here, the 1 can be anyhow. But we need to get these exact values. Good. Subject to. This will be our first constraint, second constraint, third constraint. So our first constraint, this is x1, x2, x3, x4, x5, x6, x7. So our x1 is 5x1 plus 3x2 plus 3x3 plus x4 plus x5 plus x6 plus x7, which is 0. I will not write it. So that will be our first constraint. But if you come here, if you come to the question, it's equal to 100. So equal to 100. Let's go to our second constraint, 0, 0. I'll not write the 0, 0. I'll start from here. That is x3, x1, x2, x3. That means x3 is 1. x4 is 2, x5 is 0, I'll not write it, x6 is 1, x7 is 3. And that will be equal to, second constraint is 80. And our third constraint, this will be our third constraint, x1, x2, x3, x4, x5, x6, x7. x1 is 0, I'll not write. x2 is 1. So we have x2, x3 is 0, I'll not write. x4 is 0, I'll not write. x5 is 2, x5, and this is x6, x6 equal to, in our third constraint under the 10, the third constraint is 60. We have 60. This is your L.p.p model. This is your L.p.p. This becomes your objective function. These are your constraints subject to non-negativity constraint. So we have x1, x2, x3, x4, x5, x6, and x7, all greater than or equal to 0. That is a non-negativity constraint. So this is your L.p.p model from that question.